Hey, Algebra One, no matter where you are in the world, whatever time of day it is that you're watching, hope you're having a great one. Just a little heads up. The first thing before we talk about anything on here, this number in the range, I'm going to rewrite this. This needs to be 4, 8, 12, and 16. Change that first before I start talking. Change that first before I start talking. Got that? Done? You sure? Okay, fantastic. All right. We are on Understanding Functions 2, or UF2, Understanding Relations and Functions. So we got these little things again, right? We got these, highlighted words we probably need to know. We've introduced one of those in the last target, or two of those in the last target, but let's start with the first one there, a relation. A relation is a set of ordered pairs. It gets an X and a Y. The X is the input. I'm even going to do that one. And Y is the output. Input and output. Remember that. The domain is all possible inputs of a relation. Again, domain inputs, X values, things like that. The range, those are your outputs, the Y values. For example, the given relation represents the number of whole wheat cracker boxes sold and the money earned. In other words, if I sold one cracker box, made $4, 2 made 8, 3 is 12, and 4 is 16. The domain is the X values. The domain, those values are the X values. 1, 2, 3, and 4. These guys right here. The range are the Y values. 4, 8, 12, and 16. Those are the range values. Those are the range values. We can do a lot with these relations. We can do a lot of these. For the following relation, so I got a new one here. For the following relation, the input X is the ages of boys and their output Y is their corresponding height in inches. So 7 years old, 41 inches, 8, 45, 9, 49, 10, 52, 10, 53, 11, 55, and 12, 59. Do you have to memorize those? Absolutely not. There's no reason to. There's no reason to, but let's put them in a table here. Let's put this is our set. Let's put this set in a table where the age is represented by X and the height is represented by Y. So I've got 7 and 41. I've got 8 and 45. I've got 9 and 49. 10 and 52. 10 and 53. 11 and 55. And also 12 and 59. Now we've seen right there, there are two separate ways to represent this relation. I have a set of numbers, that's this guy right there, and I have a table of numbers. Well, what's another way? Like, kind of gave it away because it's down on the bottom there. Plot the points on a graph. Plot the points on a graph. So once again, we have our X, age in years, Y is height in inches. 7 gives me 41. 8 is, I got a 45. 9 is a 49. 10, I have 52 and 53. Well, that's closer to 54. Let's just go with 52 and 53. Just pretend like it's not that far up. 11 is 55 and 12 is 59. So now we've just seen it three different ways. Now we've had the set. We've got our set here. We've had our table here. That's pretty bad. And now we've had a graph here. Fantastic. We've just taken that same data set, that same relation set, and looked at it in three different ways. Well, let's see what we got next. So next we have, again, we're on the next page now. It says complete the mapping diagram. We've got 4 ways to look at this data. Very interesting. Okay. And what a mapping diagram is, you put all the inputs on one side. These are my X or my inputs, or my Y or my outputs. And then you draw arrows from the inputs to the outputs. 7 went to 41, 8 went to 45, 9 went to 49, 10 went to 52 and 53, 11 went to 55, and 12 went to 59. You will notice that we did not repeat 10. 10 is in there one time, even though it's on the other data sets twice, right? It's in that initial data set twice. 10 goes to 52 and 53. The domain is the X values. Don't repeat X values if they repeat. My domain, 7, 8, 9, 10, 11, and 12. This was my domain. My range are these values are 41, 45, 49, 52, 53, 55, and 59. Oh man. And 59. And then you see that one right there, the discussion part, right? The number 10 appears twice in the X column of the table, but we only write it one time in the domain. We don't write, there we go. We don't write repeated numbers, okay? So this target is understanding relations and functions. Well, what's a function? A function is a type of relation. So relations and functions are related, right? Related. A function is a type of relation where there is only one output for each input. So again, this right here, highlight it, square it, do what you got to do, put a little star next to it. For every input, there is a unique output value. We're going to talk about what this means as we move forward here. But let's look at an example. This example says, give the domain and range of the relation, state the corresponding outputs for the given inputs in context. We'll talk about what that is down here, and then explain whether the relation is a function. Well, in this case, we have this data set in three ways. We've got it as a table, as a graph, and as a mapping diagram. Okay. Well, let's look. I've got 40 students go to 2 classrooms, 45 to 3, 50 is to 4. Our domain are my X values right here. And the domain represents the number of students, right? This guy right there. The range are my Y values, 2, 3, and 4. And that represents the number of classrooms. Now let's talk about the inputs. If I input 40, again, because these are inputs, if I input 40, my output, man, let's try this again. My output is 2. If I input 40 students, I output 2 classrooms. If I input 45 students, I get 3 classrooms. If I input 50, I get 4 classrooms. And let's look here. I especially like it. Let's see. Let's start with a table. Do I have any repeated X values in the table? I have 40, 45, and 50. Nothing repeats. There we go. Do I have any mapping diagram values drawing to, I don't know, 2? Does 40 go to both 2 and 3 or 2 and 4? It does not. Each input only has one arrow coming from it. Now we'll talk about a case where you can have multiple inputs going to the same output, but in this case, we have every input has exactly one output. Now in a graph, we're going to talk about this, but we're going to come back and I'm going to let you think about this one. We have a little line test. I'm going to give you a little hint. Might jog some memories here. We have a line test to determine if a relation is a function or not. But this relation is a function because every input has exactly one output. Okay, we've talked about why that is in the table and in the mapping diagram. We will come back to the graph here in a second. Next example. The given relation represents the amount of gas in gallons and the distance traveled in miles from that amount of gas. Fantastic. If I have 10 gallons, I travel 150 miles. 16, I 240, 17, 240, 20, 300. So I got this data, I've got it represented 3 ways. I've got it in a table. In a table, in a graph. Hope you're noticing the pattern here. And a mapping diagram. and a mapping diagram. And so what's that look like? What does that look like? That's a good question. Let's see what we've got to do. The domain are my X values, and it doesn't matter which thing you pull it from, which table, graph, or mapping diagram you pull it from. You just got to have the domain values. The domain values, again, are my X or my inputs. I've got 10, 16, 17, and 20. And these represent gallons of gas. The range, that's my Y values. Those are my Y values. That represents distance in miles. I'm going to write that first. Distance in miles. And those values are 150, 240, and 300. I did not repeat 240. I know it's there twice. I only wrote it one time. You just need to write everything one time. So let's talk about inputs versus outputs. If I input 10 gallons, there's an output of 150 miles. If I input 16 gallons, I have an output of 240 miles. If I input 17 gallons, there's an output of 240 miles. If I input 20 gallons, there's an output of 300 miles. Is this a function? Why or why not? Let's go back and look at the table. Just ignore the Y values for a second. Don't actually cross them off. Ignore the Y values for a second. Look at the X values. Are any of these values repeated? The answer is no. This is a function. Do any of these X down here in the mapping diagram, is there more than one arrow coming from each input? No. We have a case where I've got two inputs going to the same output, but each input only has one arrow coming from it. This is a function. This relation is a function. Each domain value is paired with exactly one range value. You can think about that reflect question on your own. You can check it in the teacher's edition that's posted on Google Classroom. It's a good question. Just a nice one to think about. Let's go ahead. This would be a great time for you to hit a pause real quick as we move forward, okay? Because we're doing your turn. We're doing your turn. So go ahead, make sure you've hit pause. You've take a minute to think about it. You've gone back and re-watched it if you needed to. Hit pause, try this out. Give the domain and range of each relation, and then interpret them in context. That just means, what do they mean? What do they represent? Represent. State the corresponding outputs for the given inputs in context. In other words, if I input 2, I output 4. Input 2 books sold, I output $4 in price. And explain whether it's a function or not. Well, here we go. We've got our table. Oh, yeah, hopefully you hit pause. Then you're going to come back. Pause. Okay. The relation represents the number of books sold and the price for the corresponding number of books. 2 books sold is $4. 3 books sold is $6. 4 is $7. And 5 books sold is $9. There's this data represented as a table, as a graph, and as a mapping diagram. The first question, the first part says, give the domain and range. The domain are my X values. That is 2, 3, 4, and 5. The range, those are my Y values. Those are 4, 6, 7, and 9. The domain represents the number of books sold. Number of books sold. the Y values, the outputs, the range represents the price. Represents the price. We've done our first two things. We've found the domain and range. We've said what they were in context. Now here we go. Here's the other part, right? 2 books. So input 2 books. I'm going to put my input and my output here. If I input 2 books, my output is $4. If I input 3 books, my output is $6. If I input 4 books, my output is $7. And if I output 5 books, my output is $8. So we've done those things. We've found the domain and range. We've put them in context. We've talked about our inputs and outputs in context. And now we got to say, is this a function? I think that's the last part, right? Is this a function? Let's look at the table. Do I have any repeated values in X? No. That's Spanish for no. Did I have anything? Do I have any values here in my mapping diagram? In my inputs, do I have any inputs which have 2 arrows going from them? No. Since they all exactly have 1 arrow coming from them, this is a function. This relation is a function. This relation is a function. Okay. If you haven't paused and done number 4, go ahead and do that. Go ahead and do that. I'm going to go ahead and just keep it going. We've got our table. We've got our graph. We've got our mapping diagram. We've got our domain of 20, 30, 35, and 60. That is time in minutes, because that's what it says right there, and right there, and right there. Those are all my inputs. My outputs are my range. My range values are 50, 85. Oh, don't have to write that one twice. And 100. And that's represented by calories burned. And I know that because that's right here, and right here, and right here. So we found the domain and range. We put them into context. Let's do that whole input-output thing again. Input, output. If I input 30 minutes, oh, let's start with 20, don't we? If I input 20 minutes, I output, whoa, 50 cals. If I input 30 minutes, my output is 85 cals. If I input 35 minutes, my output is 85 cals. If I input 60 minutes, my output is 100 calories. So we've done many things. We've found the domain and range. We've put it into context. What does it mean? We've talked about the inputs and outputs in context. Is this a function? Do you see repeated values in the X column? No. Do you see more than 1 arrow coming from any of those mapping diagram spots? No. This is a function. This relation is a function. This relation is a function. Okay, lot to think about, but we're almost done here. We're almost done. Let's take 1 more minute. If you haven't already, go ahead, push pause, and we're gonna come back to the vertical line test. Okay. Hopefully you've unpaused, shaking it off for a second. Understanding the vertical line test. So we've talked about how to look for a table in the mapping diagram to see if it's a function or not. What does the graph look like? Well, we've got this vertical line test. a test called the vertical line test. I sometimes abbreviate this. You might see it as VLT. It states that a relation is a function if and only if. If and only if. Here's a fun fact. If and only if, there you go. If and only if a vertical line does not pass more than 1 point on the graph of a relation. This goes back to this first example. I'm going to go all the way back to the very first page where we had this graph right here. I'm going to blow this graph up a little bit. This states that if I take any vertical line, I'm going to do a dotted vertical line through any vertical line. If it touches more than 1 point, it is not a function. That only touches 1, 1, 1. Uh-oh. Uh-oh. This relation is not a function because a vertical line touches 2 points. That's the graph that is right here. Does any vertical line touch more than 1 point? Yes. This one right here touches twice. Touches 2 points. This makes it not a function. It fails the vertical line test. If it passes the vertical line test, if you draw a vertical line, any vertical line, and it only touches 1 point, it is a function. This one does not pass the vertical line test. Let's go back to that other example here. Another example, we had, what was it? It was, I don't remember the numbers. I should have wrote them down. That's okay. We're going to remember them here. It's 2 pages ago, wasn't it? 10, 150. 10, 150. Oh, is it 16 and 17? Doggone, I should have wrote them down. 16, 17, and 20. 16, 240. 17, this is 17, 240. And 20, 300. Again, that's just going back a couple pages and find this one. If I draw vertical lines with all these things here, if I draw a vertical line here, only touches 1. Here, touches 1. Don't make fun of my vertical lines. I do the best I can. It only touches 1. Only touches 1. Does any vertical line touch more than 1 point? No. Since a vertical line does not pass through more than 1 point on the 1 point, the graph passes the vertical line test. So the relation is a function. Yep. Why does the vertical line test work? It is the same concept as everything else. Each input, if an input has more than one output, it's going to fail the vertical line test. You're going to have 2 arrows from the mapping diagram, or they're going to be 2 of the same number in the input part of the table. They're all the same thing, just looking at them differently. Okay. So your turn. Great time to pause right now. You should be able to tell these very quickly. Does it pass the vertical line test? You can pause it or not. It's up to you. It doesn't matter which, on number 6, doesn't matter which vertical line I draw. Again, this is the function we're looking at. This is a function. Sometimes you'll see this abbreviated as FN. Is a function because it passes the vertical line test. Number 7, right away. Not a function. Why was number 6 a function? It passes the vertical line test, or it passes the VLT. Number 7 is not a function because it fails the VLT, the vertical line test. That's what I got for you on this one. We've already gone through these things. We've already kind of gone through these things as in our discussion. So now is the time where you get some practice done. Hope you guys are doing well. Take care. See you later.